this video, I'm going to be talking about the non-inverting comparator. So before we do anything, let us draw the circuit diagram so that we can make proper comparisons. So the circuit diagram will look like this. The output is there, okay? Positive terminal, negative terminal. So what will be different is that here we're going to have the reference voltage. Here we're going to have the input voltage here. So a positive VCC. Here we're going to have negative VEE or SS if you want, or GNC if you want. Whichever notation you want to use is welcome. So this one still remains the inverting terminal. This is still the inverting terminal. Okay. This is going to be the non-inverting terminal. Non-inverting terminal. Non-inverting terminal. Okay. So it will look like that. So now what's going to happen is that how does this non-inverting comparator work? The non-inverting comparator, the way it's going to work is that the reference voltage is going to be supplied to the what? The inverting terminal. Okay. So reference voltage is supplied to inverting terminal. Okay. Reference voltage is applied to inverting terminal. So the reference voltage you put here at the inverting terminal. Then two, I'm going to find that the input voltage is supplied. Input voltage is supplied at non-inverting terminal. Supplied at non-inverting terminal. So reference voltage is supplied here at the inverting terminal. Then input voltage is supplied here at the non-inverting terminal. And this is how this comparator operates. And that's why the reason why it's called a non-inverting comparator is because the input voltage is supplied to a non-inverting comparator. Called non-inverting. It's called non-inverting. It's called non-inverting because input voltage is supplied. Because input voltage is supplied at non-inverting terminal. So that's why it's called a non-inverting, because input voltage will be supplied where? Will be supplied there. So what are the results? Okay. So the results are I. If the reference voltage happens to be greater, if reference voltage is greater than input voltage, in that case the output voltage right, is going to be negative VSAT, negative VSAT. This is to indicate that the output will be coming from this terminal, right? Because reference is great. So if we have the situation is the other way around, where we have the input voltage being greater than the reference voltage, okay, what will happen in that case is that the output voltage is going to be positive VSAT and positive VSAT. The reason why it's positive VSAT and positive VSAT is to indicate that in that case, because the input voltage is greater than the reference voltage, so the output signal will be coming from this terminal here, become the output. So basically that is it that you need to understand in the operations of the what? The operations of the non-inverting comparator. But we're still going to express that through a sinusoidal input circuit signal diagram or graph, and also the output graph. So what is going to be the difference? So how are the input and the output graphs going to look like? Okay, input and output graph. So the input and output graphs look like this. Going to have a zero here, your voltage in positive direction. Okay. So signal will go up, right? Signal go down, signal go up, signal go down again. Here we have a difference of time in the what? Time in the x. Okay. Then the output, so this is sinusoidal. Sinusoidal input signal. Sinusoidal input signal. And from there, we're going to have an output diagram like that. So here, we have a neutral point of 0, we have VSAT, and we have negative VSAT. So how does a non-inverting comparator operate now at a non-inverting terminal? What will happen is that when the input signal goes up, the signal will also go up here. When the signal goes to go down, it also begins to go down. When it's really down, it also going to be at this point down. When it starts going up, it also starts going up, like just like there. When it is up in operation, it's also going to be up. It starts going down, it will be down until to follow that pattern. So this is the difference between the non-inverting terminal and the inverting terminal of a comparator. In a non-inverting terminal, like if the signal says it's high, then it means the internal circuit is actually high also. But on an inverting comparator, this is for the non-inverting comparator. This is what happens in the internal circuitry system. But on a non-inverting comparator, right? On the inverting comparator, it's going to be the opposite. When the signal is up, here it's going to be down. Here, when it's down, here it's going to be up on the output. So that is the difference between an inverting comparator and a non-inverting comparator. So this act of output signal crossing the zero here, going from positive VSAT to negative VSAT, this is going to be called a non-inverting. It's going to be called a non-inverting zero crossing detector. It's going to be non-inverting zero crossing. Non-inverting zero crossing detector. That is what it's going to be called. So what is this really about? So this is the change, right? This is the change of output signal. Change of output signal from positive to negative. Negative crossing zero line. Okay, so that is what the non-inverting zero crossing detector is. So I'll talk about another concept called the sinusoidal what? Sinusoidal. I'm going to talk about these waves here that we have here. So these waves are called sinusoidal what? Sinusoidal signal inputs. So what are they called? What are sinusoidal input signals? So in the next video, I'm going to talk about sinusoidal input signals.